Today we are going to summarize the concept of moment of inertia for different bodies, starting with the moment of inertia of a rod along the axis perpendicular to the center and passing through it. That is called centroidal axis. The moment of inertia comes out to be equal to 1 upon 12 ml square. Again, the moment of inertia of a ring about the centroidal axis, the moment of inertia is mr square, where r is the radius of the ring. Taking a disc, the moment of inertia along centroidal axis will be half mr square. Taking a hollow sphere, the moment of inertia along the centroidal axis will be 2 upon 3 mr square. For a solid sphere, the moment of inertia will be 2 upon 5 mr square. Now last, in the concept of moment of inertia, we have to calculate perhaps the radius of gyration. Firstly, we will have to understand what is radius of gyration. In order to understand the concept of radius of gyration, let's again take a rigid body of any irregular shape. Let this be the axis of the rigid body along the center, called the centroidal axis, denoted by I. Let the mass of the rigid body be m, and let the different component of rigid body be placed at different points along the axis. Let their mass be m1, m2, m3, m4, and having the distance r1, r2, r3, r4, rn respectively from the axis. Let us consider that the center of mass of this rigid body be at this point P and its distance from the axis of rotation be k. We define the radius of gyration as the perpendicular distance of the center of mass of the rigid body from the axis of rotation. The moment of inertia I can be written as m1 r1 square plus m2 r2 square plus m3 r3 square going on to mn rn square. For the time being, if the masses of all the constituent particles is taken to be equal, the moment of inertia I can be written as m is taken to be common, and it is the sum of the square of the distances from the different masses from the axis of rotation. Considering the whole mass to be concentrated at the center of mass, the moment of inertia of this given rigid body along this given axis with respect of center of mass can be written as mk square, and this will be equal to the calculated moment of inertia. Since we have considered n particles having equal masses m, thus the total mass of the particle m will be equal to n times of a small m. So from above we can write n times of a small m into k square. So k square can be written to be equal to, and thus the radius of gyration can be calculated as the square root of the square of distances of different particles, or mean square of distance of different particles from the axis of rotation. We can also calculate the radius of gyration of uniform mass distribution. For example, we can say, since the moment of inertia of a rod along centroidal axis is 1 upon 12 ml square, we have to calculate the radius of gyration. We can see I can be taken as mk square, which will be equal to 1 upon 12 ml square. So k square will be equal to L square upon 12. K will be equal to, for a ring, so mk square or k can be written as equal to r.